In 11.1, we're going to solve quadratic equations. But a quadratic equation, we're going to call it in the term of ax squared plus bx plus c, and we're going to let it equal to 0, where a, b, and c are any number. As an example, 4x squared plus 4x minus 5 is equal to 0. That is in standard form. Now, in the second one, the right side is not equal to 0, so we move everything to the left in this case. Now we'll call it 3x squared minus 4x plus 8 is equal to 0. And that will be how we want it. Another rule we need to remember is if two things multiplied, I'm calling it a and b, two things multiplied equal to 0, either a 0 or b 0. So an example, let's take a look at this thing, x squared plus 4x plus 3. We're going to solve it using the zero factor property. I'm going to factor my left side. I'm thinking two numbers and multiplied equals 3, but added is equal to 4. My numbers are 1 and 3. So I'm going to factor the left side as x plus 1 and x plus 3, and this is equal to 0. Because two things multiplied equal to 0, I'm going to say x plus 1 is equal to 0, and x plus 3 is equal to 0. Solve the left side. So I get that x is equal to negative 1. Let me move the 3 over. I get x equals negative 3. Now looking at example B, the right side is not equal to 0, so let me move the 9 over as x squared minus 9 is equal to 0. But 9, I'm looking at this as x squared minus 3 squared is equal to 0. So that is the difference of the squares. I'm going to factor that as x minus 3, x plus 3 is equal to 0. So I'm going to say that x minus 3 equals to 0, and x plus 3 is equal to 0. Solve each equation. X happens to be 3, and x happens to be negative 3. Now, we're going to learn the square root property. The square root property says if the variable is squared and by itself, why don't we just get the square root of it? So looking at example A, I'm going to do the square root of each side. But I know the square root of 16 is either 4 or negative 4. So my answer will end up being, in this case, x is equal to 4 or x is equal to negative 4. My example B, that x squared is not by itself. So let me move the 5 over. So I get that x squared is equal to 5. Now that it is by itself, I'm going to do the square root on each side. And I'm going to end up getting that x is equal to the square root of 5. But x is also equal to the negative square root of 5. On example C, I'm going to start by moving the negative 32 as a positive 32. So I get that 5m squared is equal to 40. Let me divide both sides by 5. I get that m squared is equal to 8. When I do the square root on each side, I end up getting that m is equal to the square root of 8, and m is also equal to the negative square root of 8. However, in chapter 10, we learned how to simplify a radical. So square root of 8, I'm going to call this 2 radical 2. So that means m is equal to negative 2 radical 2. The square root of property says if x squared is equal to k being any number, x is equal to the positive square root of that number, and x is equal to the negative square root of that number. Now, Galileo Galilei developed a formula for freely falling objects, d equals 16t squared, where d is the distance in feet that an object falls, disregarding air resistance in t seconds, regardless of weight. The Leaning Tower of Pisa is about 180 feet tall. Use the formula to determine how long it will take an object dropped from the top of the tower to fall to the ground. So if I'm dropping something from the top to the ground, so the distance it's going to travel is the height of the tower, which in this case is 180. So I'm just going to go 180 is equal to 16t squared. To get the t squared by itself, let me divide both sides by 16. And I get that 11.25 is equal to t squared. I want to do the square root of each side. And The square root of 11.25 happens to be, according to my calculator, 3.35. So that means t is equal to 3.35 and t is equal to the negative 3.35. Now the negative time, that means that if I drop something right now, it will fall 3.35 seconds ago. Now it cannot drop in the past, so I'm not going to accept a negative time. So my answer in this case is 3.35 seconds. Now looking at this equation, I'm going to do the square root to get rid of the square sign. So the left side, I'm just going to get x minus 3 is equal to 4. And I'm also going to get x minus 3 is equal to negative 4. If x minus 3 is equal to 4, let me move the 3 over. I get x is equal to 7. On this other case, let me move the 3 over. X is equal to negative 1. On the right, on example B, I'm also going to do the square root on each side. And I get that x plus 1 is equal to the positive square root of 6. And x plus 1 is equal to the negative square root of 6. Let me move the 1 over. Those two numbers are not like terms, so I cannot combine them. So I'm just going to say x is equal to negative 1 plus square root of 6. And x equals negative 1 minus the square root of 6. Now here, let me do the square root on each side. So I get that 3r minus 2 is equal to the square root of 27, but we learned in chapter 10 how to simplify by radical. I'm going to call that 3 radical 3. I'm also going to do an equation. 3r minus 2 is equal to negative 3 radical 3. Okay, so in the first one, let me add a 2. So I get 3r is equal to 2 plus 3 radical 3. Let me divide everything, each side by 3. So r is equal to 2 plus 3 radical 3 over 3. This other one, let me add a 2. So I have that 3r is equal to 2 minus 3 radical 3. Divide each side by 3. So I get that r is equal to 2 minus 3 radical 3 over 3. Same thing with negatives. I can do the square root of sign. So I'm going to get that x. Now, the square root of a negative 15th is going to be I square root of 15th. Remember, when it's a negative, I can take out the I. And I'm also going to get that x is equal to negative I radical 15th. Now, radical 15 cannot be simplified, so that's pretty much it. Now, example B, once again, I'm going to do the square root on each side. So I get that t plus 2 is equal to 4i, and then t plus 2 is equal to negative 4i. Let me subtract the 2 on each side. So I get that t is equal to negative 2 plus 4i. And then t is equal to negative 2 minus 4i.